For the counter shown in the figure, the present count is 0100. Count after 2 clock pulses will be. Here D1 equals to Q4, D2 equals to D1, that is Q1, D3 equals to Q2, D4 equals to Q3. We know that Q1, Q2, Q3, Q4 initially 0, 1, 0, 0. After giving the 1 clock pulse, Q4 is shifted to D1. It doesn't mean that. It means D1 equals to Q1, we know. So this is 0 and Q1 spread to the D2, that is Q2, that is here shifted to 0, here shifted to 1, here shifted to 0. Next clock pulse, this 0 here, this 0 here, this 0 here, this 1 here. So after 2 clock pulses, the output is 0, 0, 1. Here option B is correct. An 8085 microprocessor uses all available jump instructions each only once. For this program, the total memory in bytes occupied by the conditional jump instructions is. In case of 8085 microprocessor, the total number of jump instructions are 9, that is including jump. Jump, here is address. Here jump on no carry, jump on carry, jump on positive, jump on negative, jump on parity even, jump on parity odd, jump on 0, jump on non-zero. So if we consider only the space occupied by the conditional jump instructions, those are 8 conditional jump instructions are available. Each conditional jump instruction occupies 3 bytes of memory. Hence, total memory space occupied by the conditional jump instructions is 8 into 3, which is equals to 24 bytes. Hence, option C is correct.
3-phase 50 Hz 4-pole 15 kilowatt 1400 rpm induction motor is having rotational losses of 1 kilowatt. Okay, he has given rotational loss of 1 kilowatt. Okay, and NR is equal to 1400. We can find NS as 120 into F, that is 50 by P4. Okay, 1500 rpm. Now what is slip here? Slip is equal to NS minus NR by NS, that is 1500 minus 1400 by 1500, which is equal to 0.067. Okay, now we have to find here rotor copper losses at full load. Rotor copper losses is equal to S times of air gap power PG. Okay, that is nothing but S times of air gap power PG is, which is equal to PSH plus rotational losses. Okay, now what is PHS there? PSH is equal to shaft power. Okay, that he has given as 15 kilovolts. Okay, so 0.067 into 15 plus rotational losses as 1 kilowatt. So this is 15 plus 1, 16 kilowatt, which is equal to 1.067 kilowatt. This is option C is correct answer. In this question, we have to find mechanical torque developed by the 3-phase 50 Hz 4-pole induction motor. Okay, given frequency is 50 Hz, number of poles is equal to 4. Synchronous speed of the induction motor is given as 120 into F by P, which is equal to 1500 rpm. Torque developed by this induction motor is Pg by omega s, that is air gap power by synchronous speed in radians per second. Air gap power is given as 3 times of I2 square into R2 by S by 2 pi ns by 60. Okay, this is equal to 3 times of rotor current is given as 20 amperes. So 3 into 20 square, R2 by S is total resistance in the rotor circuit, that is 20.5 divided by 2 pi into 1500 by 60, it is equal to 156.6 Newton meter, that is option A. Okay. He has given a 8-pole DC generator which is having simplex wave-wound armature winding, okay, containing 32 coils of 6 turns each. What we have to find here is induced voltage. Okay, induced voltage is E is equal to 5 ZNB by 60A. Okay, we know phi is equal to 0.06 Webers. Okay, and N is equal to 250 RPM. Okay, P is equal to 8. And what about A value here? A is equal to 2. Okay, since it is wave winding, A is equal to 2. If it is lap winding, A is equal to P, which is equal to 8. Okay, he has given a wave winding, so we have to substitute A is equal to 2. Now, important thing here, we have to find number of conductors Z. Total number of conductors Z is equal to 2C into NC. Okay, 2 into, we know number of coils in this armature winding is 32. Okay, and each is having 6 turns. Okay, so 2 into 32 into 6, which is equal to 384 conductors. Okay, now E is equal to phi is 0.06, number of conductors is 84 into 250 into 8 by 60 into 2. So this is equal to 384 volts. Option C is the correct answer. Okay, he has given a 400 volts 50 kilo volt ampere 0.8 power factor which is leading. Delta is connected for 50 hertz synchronous machine. Okay, synchronous reactance XS is equal to 2 ohm. Okay, negligible armature resistance. So RS is, let us take it as 0. RA is 0. The friction and windage losses are, okay, this is, they have given friction and windage losses as 2 kilowatt. Core loss, okay, core loss is 0.8 kilowatt. If shaft is supplying 9 kilowatt load, okay, he has given P shaft which is equal to 9 kilowatt load at a power factor of 0.8 leading. Okay, this is leading. Then line current drawn by this machine is, okay, now we have to find line current. Okay, to find line current is means is drawn from the supply here. Okay, drawn from the supply, so sending end power is equal to, this is 3-phase machine, so root 3 VL IL cos phi. Okay, now what is line current here? I line is equal to sending end power by root 3 into VL IL cos phi. Okay, with root 3 VL cos phi, which is equal to, now we know that line voltage he has given as, what is the line voltage here? He has given as 400 volts. Okay, unless and until it is specified in question it has phase, we should take line voltage. Okay, now what is line voltage? Root 3 into 400 into, it is operating at 0.8 leading power factor. Okay, now what is sending end power here? Sending end power is equal to receiving end power plus losses. Okay, that means what is this sending end power here? 9 kilowatt, which is a useful power at the shaft. 9 kilowatt plus 2 kilowatt plus 0.8 kilowatt, which are friction and windage losses plus core loss in the machine, divided by root 3 into 400 into 0.8, which is equal to 21.29 amperes. Option C is correct.